Well, great. Let's get started. Like I mentioned, if you have any questions, shoot them up in the Q&A box. We'll be sure to answer those real time as they come in. Brendan's back behind there. He's going to shout those out as we go if anything comes up with this topic. So I kind of jumped into it already. And we have two styles of pumps when we're working with solar pumps. We have our helical style. That one's over here. I'll pull this one up. A shorter barrel, which is up here. This is our pump end, our wet end, sometimes we call it. And then our motor down below. Motors are all the same. They can drive either a helical style or a centrifugal style pump end. So here is just the outside of what a helical pump looks like. That is our 3-inch size of pump. It's one of our smaller lines, but it's one of the most versatile pumps we have, and it covers a wide range of applications. With this smaller style, it's probably 60 to 70% of our customers are going with that. It will talk about the pros and cons of where we can use that. We'll get into a centrifugal style. A lot of times the centrifugal style is going to be much longer up here. That's because we have stacked impellers. There's a bunch of impellers stacked up here which generate the water pressure to get the water up and out of the well. Motor down below looks very similar here. Again, 3-inch diameter. And so this will go down a 3-inch well. It's actually like 2.8, 2.9 inches in diameter at its widest part right here. So it'll go down a 3-inch well. Great for 4, 5, 6, 8-inch diameter wells, no problem. So overall, just a longer pump end. We can look at this one. This is also a centrifugal style. Just give you an overview. This is our 4-inch pump, quite a bit heavier. It goes with the Pro Controller. 4-inch diameter, really about 3.8 inches. So it does fit within a 4-inch well. We have our motor down here, pump end up here. When we get to the 4-inch side, in the Pro system, they're all centrifugal style pumps. They all have those stacked impellers in here. So let's talk about some of the reasons why we would choose a helical versus a centrifugal style pump. So helical pump, this one here, it's very good at lower volumes and high pumping heads. And when I talk about pumping head, it means the amount of vertical lift we need to get the water up and out of the well, plus any extra pumping head, say we're going up a hill, or if we're going to a pressure system, any extra pressure we need to generate, that's all taking up that pumping head. So this one pump here, it ranges from around 200 watts of input power up to 800 watts of input power. And with this one, we'll pump anywhere from 3 to around 8 or 9 gallons per minute. But when we get up to the 8-panel model, it can do around 325 to 350 feet of pumping head. So a large amount of pumping head. And this is great. Our most common pump we have out in the field right now is this helical style pump because it is so versatile. And when we're looking at a solar pumping day, the nice part is if we're pumping, say, 5 gallons a minute, 6 gallons a minute, over a 6 to 10 hour pumping day, we're talking about 1,500 to 3,500 gallons per day, which is a lot of water, whether you're doing a household, whether you have a bunch of cow-calf pairs, whether you're going to drip lines. If you're using a lower water application, then this pump throughout that whole pumping day is going to pump plenty of water for your application. But let's say you need more than around that, 7, 8 gallons a minute. We're going to go to a larger volume pumping head. And at that point is when we switch over to the centrifugal style pump. Centrifugal style pumps generally take a little bit more power. And in general, for the same power, they don't produce as much pumping head as this helical style, but they do produce more volume. Now, that's not to say we can't get more pumping head out of them, but when we want to go to those higher pumping heads, we're going to go to a higher power pump. So instead of, say, 800 watts, we'll be up here with a couple of horsepower, and those are running anywhere from 1,500 to 3,500 watts of power. And at those power levels, they're going to far exceed what this helical style pump can do. So when we graduate out of volume for this helical pump here, and that's, like I said, around the 8 to 9 gallons per minute, we're going to go over to this centrifugal style pump. This centrifugal pump starts around the 8 gallons per minute and goes up to 15 to 17 gallons per minute. But it's not as energy efficient as the helical style. And that's one reason with solar, we like the helical style pump because it is so energy efficient. And what I mean by energy efficient, that means for every watt of power, for every amount of sunlight reaching the panels, The helical pump is going to pump more water up and out of a well than a helical style well. It's going to start up a little bit earlier in the morning, and it's going to run a little bit later into the afternoon because of that increased efficiency. The centrifugal style pumps, still very efficient, but not quite as much as the helical pump. So with this helical, we can go down to around 200 watts of power and still produce right around 4 gallons per minute at 100 to 150 feet of pumping head. So with 200 watts, that's 2 small solar panels. Usually we're pumping a lot of water. If, say, you have a 60-foot well and you just want to water some livestock, you want to fill up this 2,500-gallon storage tank behind me. A very small system, very cost-effective system is going to be a good fit for you. But when we get to higher volume and say, maybe we want to keep a lake full, maybe we want to keep a pond full, maybe we're going into a bigger tank, we're going into a 5,000, a 10,000-gallon tank, or we're doing a little bit of watering in our garden, then we might want more volume. And so we'll step up to this guy. This one doesn't run at 200 watts. It's starting at 400 watts and then goes up to 800 watts. And so at 400 watts, we're doing around, probably around 10 gallons a minute, but only up to like 75 feet of pumping head. So quite a bit less pumping head, but more volume. And you're going to be hearing that fairly often. So when we're at the same power level, we're always going to be trading pumping head for volume of water. So if we want to increase the volume, but the power staying the same, then your pumping head's going to decrease. And the opposite's true. If you increase your pumping head, your volume's going to decrease if the power stays the same. Now, we do always have the option to step up to a higher power pump, and that's going to allow us to bump those both up and then start making the trade again. And so with that, going up from the 400 to the 800 watts, this one's going to be doing around 14 gallons per minute at 125 to 150 feet of pumping head, but it's really topping out around that 150 feet of pumping head. We don't go much past that with this pump. So as you can see, same amount of power. This one's doing around 300 feet of pumping head, twice as much, but half the volume. And this one's doing about twice the volume, but half the pumping head. So that's the trade-off between these two. One of the great things about these systems is they are modular. So that means we can add on panels later. So with this guy, it's the same pump end and motor, whether they're running at 400 watts or at 800 watts. So if you find out later you want to increase your volume or you want to increase your pumping head, then you can add additional panels by keeping the controller, the pump, everything else the same, but add on in order to increase the amount of volume or pumping head. Similar thing for this one. In this case, we do have 2 different motors that go with it. We have our lower power motor around 210 watts and then our 500 watt motor. And so with that, we can upgrade from the 2 panel up to the 4 panel. And then we can also go from the 6 to the 8 panel. And we do have some options if you want to go from the 4 up to the 8. We can also help that out by adding more panels, which A, increase our volume, or B, increase our pumping head. Say you have more drawdown, or you get on the field and over time your water level decreases over time as maybe it's a drier climate, maybe your neighbor's pumping a lot of water and your water level is dropping. We can increase that and change it over time. So very versatile system. Very easy to swap up and change them around. So like I mentioned, one of the big benefits of the helical, very energy efficient, small systems, pumps a lot of water throughout the whole day. But when you're getting to higher volume, then we're going to switch over to the centrifugal style pump. Let's show you a little bit about the technology between the two of those. So the helical style, like I mentioned earlier, is called a positive displacement pump. And so that's acting in a physical manner. It's taking the water and it's basically squeezing it. And as we squeeze it, it pushes and generates pressure to push that water up and out. It's very a physical action that's going on there. And I have one of the pumping mechanisms within this pump end here. And this is kind of sitting right here. So this part is our rotor. That's the part that actually spins. That's connected to our motor. And our stator is up here. That's the part that stays still here. And as it spins, you can see that rotor spins within the stator, and water is going to go in the bottom here, and it's going to be squeezed up and outward. And this is basically like a corkscrew, basically a worm gear. Used in other places, sometimes used in air compressors, sometimes used to move very viscous, very thick fluids that just won't go through the impellers of a centrifugal style pump. But one of the downsides here is there is that physical action going on. So we do have friction. We have rubbing of our rotor against our stator. This is a stainless steel rotor. We recently upgraded it this year, and we started chrome plating it. So you can see it's very shiny, really silver metallic. That's a chrome plating. And we did that because of this mechanical action here. If you do have any sand or silt in your well, it can wear both the rotor and stator out over time because the sand goes up there and just basically acts as sandpaper inside and starts eroding things away. But one of the key benefits of this pump is it's one of the only rebuildable pumps on the market. And so that means if this ever degrades or fails out in the field, we have a lifetime warranty on this pumping mechanism. So if it degrades and you start seeing a decrease in water over time, the kits come with one replacement already. So you'll have that on hand, throw it in a drawer, put it on your garage. If you ever need it, it's about a 5-minute process in order to change this out. We take the 3 screws off the top here. There's a couple of Allen screws down in there. We include the Allen key, get those off. This comes apart. We screw the new one on, and we go from there. And you're going to be pumping as good as new after you replace this pumping mechanism. And like I mentioned, lifetime warranty. If you use it, just shoot us an email. Sometimes send us a picture of the one you pulled out. And we're going to send you a replacement for the lifetime of this system here. So super great to rebuild these pumps out in the field in about 10, 15 minutes. I actually just got an email this morning. I told them I think it was fate. Somebody emailed in and said, I had purchased a system almost 10 years ago and it finally failed. I installed the new rotor and it's as good as new. Can I get a replacement rotor? That's Drew out in Kansas. Happened to come in this morning. I had to write that down because that's a guy, he's been running this pump out in the field for 10 years. He noticed over time, maybe the last 6 months, a decrease in water, pulled the pump up, replaced it with the one he had kept in a drawer. Good job, Drew, for setting that off to the side. I probably would have lost it after 10 years. But good job, threw it in there. We're going to send him out a replacement, and I'm hoping he gets another 10 years out of the next pumping mechanism. He's going to get the chrome replacement, which is a much harder surface, and we're finding this lasts anywhere from 25 to 50% longer. So we're hoping instead of another 10 years, he gets another 15 years out of the system. 25 years would be a great run for that RPS 200 he put out in Kansas. But like I mentioned, if you have really sandy or silty wells, then this can wear out a little bit faster than Drew had over 10 years. Sometimes in a sandy well, we're looking at anywhere from a year, 3 years, 5 years. Just really depends on the aggressiveness of that sand or silt on how quickly you're going to start to notice water decline on this. We got a quick question here. We'll throw that out.
Yeah, we got a question from David or a comment. I have a helical pump at 240 feet with a check valve at pump and 3/4 inch poly pipe that I need to pull out and replace stator and rotor. Any advice to simplify this process would be greatly appreciated.
Yeah, a fairly simple process. My best recommendation would be have a buddy come over, grab some sodas, grab a case of beers if that's your thing. Make an afternoon out of it. Probably take you an hour and a half because pulling that can take a little bit of time. Get that up there. Pull your truck up behind. I always like not working in the dirt on this. I try to eliminate as much of the dirt from getting back down in the well as possible. So you put down the tailgate, work on the back there. Once you get it up, it's going to be about 10, 15 minutes. If you have any concerns, if you haven't changed any of the wiring, then throw it right back down. Should be running great. If you do switch up the wiring, you might want to bring a bucket of water or fill up the bucket of water before you pull the system up. Test it in the bucket before you put back down, just to make sure we're running in the right direction. Very similar to a centrifugal style pump. It runs in one direction. In the other direction, it's not going to run. We want to check that out before you put it back down in case you need to do any troubleshooting, making sure everything's running right. It's much easier in a bucket at the surface versus putting it back down the well. But if it's one of our pumps, feel free, shoot us a message right after you do that. We'll send you out a pumping mechanism. If you lost your pumping mechanism, no problem. Shoot us a note. We'll send one out so you have that in advance. Then you just undo these bolts. We have a YouTube video if you want to check that out for how to do this replacement. But very simple. At the end, it's going to run like the day you put it in. The motor doesn't degrade over time. It's a brushless DC motor. There are no brushes to wear out. And so basically, once you replace this, it's going to be running about the same as the day you put it in.
And with that 240 feet of poly pipe, that shouldn't be an issue for you guys to pull out in an afternoon.
You know, it's a little heavy, but 2 people can do it. You just sometimes you just buckle down and start pulling. I've installed by myself up to around 170. It might have been 225. It was somewhere in there. One person. At the end, when I was placing it, I could still lift it, but I wouldn't want to be pulling hand over hand by myself with that. I'd want a buddy to swap off with. Sometimes when I did that one, I made a clamp, and so I could clamp the poly pipe, let it sit there, catch my breath before pulling up another 50, 100 feet. Okay, we have one more question here.
Yeah, follow up. How long have we been doing the chrome-plated rotors?
Chrome plating rotors came out this year. And so if you do find you have a sandy well and you want to switch over to the chrome plated rotor, give us a call. Instead of putting down another of the old style, we're happy to send you out one of the chrome plated ones. But if you already ran 5, 10 years like this, Drew, you put the same other one in. Like we said, it's about 25 to 50% longer depending on your exact well condition. So if it's only lasted a year, you might want to switch over to chrome. Sometimes we're seeing people double, even triple their lifetime of it. But if you already ran 10 years like Drew, I throw the same thing, same one he has back down. And if he ever has to pull it again, he can swap to a chrome one.
All right. Great questions from David. Thank you.
Yeah, thanks a lot, David. Those are excellent questions. Great. So like I said, even with the chrome plated pumping mechanism, there are some cases where we have a really sandy or silty well. If you've seen the first virtual field day, we installed on our test well we have back in the back of our property here, and this is a sandy well. When we fire this thing up, sandy, muddy water comes up, and we've ran a helical style pump in there for quite a while. It'll run 6 months to a year, sometimes a year plus. But if you don't want to replace the pumping mechanism that often, or you just know you have a sandy well, then we might want to talk about going to a centrifugal style pump. So the way a centrifugal style pump is it's not positive displacement. It's not operating with like a physical interaction between the rotor and stator. Instead, I wish we brought some, but instead it has impellers inside. So think of an impeller kind of like a spinning fan blade, like a spinning a turbine, a propeller on a ship. Instead of physically squeezing water in a physical motion, it's accelerating the water. And so it's pushing it out. So the way these impellers work is the water comes up through the center, and using centrifugal motion, because it's spinning, it shoots the water out the sides and up. And we stack those impellers in here. So this one, I believe, has 6 stacks. 1, 2, 3, 4, 5, 6 in here. And so each of those impeller stacks is going to accelerate the water up and outward with a little bit more pressure. So when we add up all those stacks together, we start to get higher pressure water coming out the top. And the nice thing about that is we can vary the aggressiveness of that propeller, of that impeller, on each of those. And then we can also add as many as we want to increase pressure. So when we're talking about a volume series pump, usually they're going to be much shorter because we don't need as much pressure, but we want to grab more water and push it up and out. When we're doing a higher pumping head centrifugal pump, then we're going to add more impeller stacks there in order to increase the amount of pressure we can generate. And so, like I mentioned, when we go over to this one and we're swapping from this helical style, we would do this for 2 reasons. One is we just need more volume of water that we can't achieve with the helical style. Or 2 is we have a really sandy well, or say we're pumping out of a lake, we're pumping out of a canal where there's a bunch of silt and sand that's going to get it into it and degrade that pumping mechanism too quickly. Then we'll switch over to the centrifugal style. No real downsides here, that it just doesn't produce the same pumping head for the volume. And so we might need to add additional panels there. Like I mentioned, this one's going up to around 150, 175 feet of pumping head. And then once we go beyond that, and if we want to stay with a centrifugal style pump, we're going to need to switch over to our Pro system here. Our Pro system starts at the smallest or half horsepower with around 1,200 watts of power versus the 800 watts where the 3-inch pump stops. But with these Pro system, they're all centrifugal style. Once we get out of these lower power ones and we just kind of resign to the fact that we're going to need to provide this pump a lot of power, then we stick with centrifugal style from here on out. And there, like I mentioned, we can vary the pump end depending on the amount of pumping head or volume we want to produce. And so I have 2 different options here. These are both half horsepower pumps. So they use the exact same motor. This is a 3-phase 240 volt motor. If we had 3-phase power and hook this up, it would just start to run. But with this Pro controller, we can take power from our solar panels, run it through the Pro controller, and then run this motor. And that's the magic of how we're able to run this kind of AC style three-phase motor off of solar power, which is DC power. I'll go into that more next week, and we do the deep dive into the Pro system. We're going to talk a little bit more in depth on how that works and all the different applications we can do with it. But when we switch over to the centrifugal style, we have, these ones look very similar, but inside there's actually different number of impellers. This is about a 1/4 inch shorter, probably has 1 or 2 less impeller stacks in there. I'm betting it's just 1 lower because this is very similar. This guy is doing 18 gallons a minute at half horsepower. This one's doing 10 gallons per minute at half horsepower. But like I mentioned earlier, anytime we're keeping the power the same and we're changing the amount of volume, then our pumping head's going to change. And so 18 gallons a minute, this one's going to do around 103 feet of pumping head. This one's going to do the 10 gallons a minute, but since we lowered that by 8 gallons a minute, we're gaining some pumping head. It's going to do 163 feet of pumping head. This is our mid-series. This is our volume series. This is our mid-series. What I don't have here is our deep series. That'd probably be about this tall here. We add a couple more impeller stacks, and that's going to do around 5 gallons per minute, but it's going to bump that pumping head up to around 200, maybe 220 feet of pumping head. So what's really common is most of the wells will start with the helical style when we have lower volume, lower pumping head. If we want to get higher volume, we'll step up to the centrifugal 3-inch pump. And then if we step out of those, and either we need to go beyond 350 feet of pumping head, or we need to go beyond 14, 15 gallons per minute, we'll step up to our Pro Series. From this, we can cover almost any application. When we go to our 3 horsepower deep series or our 5 horsepower deep series, that's going to do around 1,200 feet of pumping head, which is a really deep well. You're talking water 1,000 feet down, and we're going to pump it up and out of the well at 5 gallons a minute. We can do that with one of these systems. It takes about 10 of our larger solar panels to produce that pumping head. The other great thing we can do is we can also do a lot of volume. With our volume series, a slightly higher power, we're looking at around 80 gallons per minute standard, but we can go even higher, 150, 250, 350. If we really want to specialize, we can get a submersible kind of like sump pump that does 400, 500, 600 gallons per minute for those really high volume applications. And again, we're going to go over all of that next week when we go the deep dive into the Pro Series and the different applications there. Great. Any questions? Yeah, cool.
Yeah, one more follow-up about that chrome-plated rotor.
Nice.
The rotor sent towards the end of last year have been chrome-plated?
Yes. So swap over was probably around November of last year, October, November of last year. We didn't announce it. We just started flowing it in. Some people actually started receiving this pumping mechanism around I believe a year and a half ago. We did a run of 50 mechanisms, and we reached out to customers who wasn't running as long as they would have liked because they had a degraded sandy well. People who are replacing their pumping mechanism every year, year and a half. We offered a little pilot program to try this out, and that's where we found in some cases 25%, some cases 50, some cases where they didn't have a lot of sand. They were really hard sand. They were doubling the lifetime of it. So instead of replacing every year, they started going every 2 years. We actually have a customer who tracks his well. Every month he does gallon per minute flow rating, and he had to replace his pumping mechanism every year, and he tracked the volume, and when he hit a certain point, he'd swap it out. And so we sent him a chrome-plated one, and it doubled the lifespan of his. Instead of replacing every year, he replaced every 2 years. And that's just a guy who was happy about the performance of the system. He was fine with pulling it up every year and doing the annual maintenance, and he didn't want to switch over to centrifugal style. We'd offer that several times. If he had wanted to switch over to centrifugal style, he probably would last basically for 5-10 years plus, even a very sandy well, because like I said, there's just no mechanical friction motion going on inside of these. So they do degrade with sand over time, but it's a much longer time span because basically it's like your fan, say your kitchen fan blowing in the window. If you threw a handful of sand in there, it's not really going to damage that fan. It's going to bounce off those the fan blades. If you look at the fan blades, they might start to get a little pitted over time if every day you felt like throwing a handful of sand in it. But it's just not going to fail all of a sudden. It's not going to fail quickly, as if you could imagine this mechanical motion and throwing a bunch of sand in here. So I don't want to make anybody worried about the helical style pump. Like I mentioned, it's our most common pump. It works great in old wells. It works great when there's a small amount of sand or silt in it. I'm talking the really degraded wells. These are the ones that probably chewed up your grandfather's pump back in the day, and he got tired of pulling the pump out and replacing it. And so he abandoned that well. And now we're coming back 10, 15 years later. It's an old well, been there 80, 90 years. If we throw the helical style in, and it just has a lot of sand and silt in it, majority of the time, the first time we fire it up, we pump that all out of there. And sometimes we have customers who, the first time they fire up that well, it hasn't been used in 20 years, it gets all disturbed, they pump out all that sand and silt. And real quickly, after a couple of months, they degrade their pumping mechanism, but they got all that junk out. They got all that sand and silt out. They developed the well a little bit. Wells like to be used. They like that water flowing in to make sure there's not sediment buildup inside of there. And they pump it all out. And then it runs for years and years and years because they got that well rerunning, reestablished, and they can stick with the helical style pump and not make it over to the centrifugal style. So majority of our customers never have a problem with their pumping mechanism. Majority of them are like Drew out in Kansas, running 10 years with the same pumping mechanism. They notice a decline after that, go out and replace it, good as new. But we do have some with the older style degraded wells. Try out a helical. Sometimes replace it one time. Usually that fixes it. If that doesn't, then we'll talk about options to go over to a centrifugal style. But if you're fine in some of those cases, just swapping out the pumping mechanism as part of your yearly maintenance, they're happy with the system. Everything's running great. Cool. Any other questions that came up?
Something that came to mind to me.
Sure.
You mentioned that the centrifugals work better if you're dealing with sediment, sand in the well. What if you have like larger debris or detritus, like maybe some small rocks that you're pumping out of a lake, or you're using it as a dewatering application? Do we have better pumps that would be more applicable to that situation?
Yeah, absolutely. Great question. So talking about if we have bigger sand and debris, you can see on these pumps, there's a screen down here. The screen is about 1/8 of an inch there. That's going to keep the large rocks and debris out. We have a lot of customers who use the centrifugal style. Well, first of all, step back. If we're going into a pond or lake, then a lot of times, if we can use a helical, but we'll probably add some secondary filtering on that. There is a video on YouTube about how to do that. Check it out. Using finer mesh and filtering, we have customers who just cover this up to prevent a lot of that sand and silt from coming in, especially when they're pumping out of a lake, a canal, an irrigation ditch, something like that. We have some guys using streams. They want to pump out of the stream up to their house. Again, we just say clear out a space for it. Sometimes we'll take a 5-gallon bucket, dig down in the stream or the pond, set that in there with a bunch of holes in it, maybe add some filtering material, some window screen mesh, something to help keep the particulate out. And they usually run great with that. It's really accessible if they need to replace that pumping mechanism, but usually that's just enough to run for years and years. But if there's times we don't want to do that, then the centrifugal style is good. This is good for a medium amount of sand or silt. So I like to say like muddy water's fine. A little bit of sand in the water, that's fine. But if we get into large particulate, say we're going out of a lake, we either want to increase the filtration by putting a pipe in there, a 5-gallon bucket, something else. We want to really avoid like stringy material, because what can happen is the stringy material can get past this filter, and then it kind of gets stuck on those impellers. And so there's a sharp edge of that impeller, and you get that stringy material, and it kind of like covers that edge of it, and we lose the sharpness, and so it no longer grabs water as quickly. You think of like a fan in your house again. If you took a can of silly string and just started spraying it all over those fan blades, they're going to be covered with all this like matted material, and they're just not going to move a bunch of air. And so in those cases, we do encourage secondary filtration. For the 4-inch, we actually do have a secondary filter if you need one. It's used on our Fountain series of pumps because those are designed to go in lakes. And so that's a mesh material that goes over here. It has a drawstring and elastic that really closes around this and provides finer filtration if you're going out of a pond or lake. We have that for our 4-inch style. We're developing it for our 3-inch. So if you're doing that, let us know. We can help you out with one of those. But there are other pumps that we can use that are centrifugal style that are made for this. Next week, I'll go over those. Those are called our dewatering pumps. They're basically a sewage pump, dewatering pump, a grinder pump, all the same name. And those are made for those solids. That one, I believe, covers a 2-inch organic solid. It'll go in the bottom of that. The blades are made to chop this material up. So it chops it up and spits it all out. So if you're doing high volume out of dirty water, we'll probably talk about going to one of those pumps.
Right.
Great. Any other questions we have?
think we're pretty much set for now. If anybody has any other questions, feel free to throw them in the chat, throw them in the Q&A. Plenty of time for those.
Perfect. I kind of mentioned this earlier. Let's talk a little bit about sizing your system, what the process would look like, because I threw a lot at you. I got a short amount of time. I can speak a little fast, get into the technical weeds here, but don't worry about all that. At the end of the day, what we find is any one of these pumps is a super reliable pumping system, and we can fit it the right one to your application. So we have a pump sizing team, and when you're going to go through the pump sizing process, they're going to help you select which one's the right one. Whether we start with a helical, majority of the time we do, because they're very cost-effective, easy to install systems. And then if we need to, depending on your exact conditions, whether that's pumping head or volume, they might step you up to one of these other systems, one of the centrifugal style. And so they'll first ask you about, what's your application? What are you pumping from? What are you pumping into? Are you pumping into a stock tank, a storage tank like I have behind me, or are you pumping into a pressurized system? From there, that's going to allow them to calculate your total dynamic head. And so your total dynamic head is, like I mentioned, is the amount of pressure we need to pump the water up and out of the well, or say out of the lake, up to wherever the pump is, wherever the water's going. How do we pump it up and out? And then what do we do with it there? If we're open discharge into a storage tank, we kind of stop at the calculation there. But if we're going into an elevated tank or we're going into a pressurized system, then we're going to convert that all to pumping head and add it all up to get our vertical pumping head. A majority of times that's less than 200, 300 feet of pumping head. And that's why this helical pump here is so versatile, because any of those applications, we can throw this in, we can vary the amount of panels you need for that pumping head. If you step above around the 300 to 350 feet of pumping head, then we're going to switch over to our Pro Series. A lot of these, we have the lower pumping head ones, but really quickly at 1 horse deep, we're going to be doing around 400, 450 feet of pumping head, and then we can go to 1.5 horse, 2 horse, 3 horse. When you get to the 3 horse, 5 gallon per minute pump, we're doing something around 1,000, 1,100 feet of pumping head. And if we really have to go big, we go to 5 horse, which is around 1,400 feet of pumping head. So depending on your pumping head, we're going to be in probably either the helical style and then the transition over to the 4-inch centrifugal style. The other one might just be pure volume. If we're looking at volume and we're less than around 6 to 8 gallons a minute, we'll use this helical. When we go past the 8, 9 gallons a minute, we're going to switch over to our 3-inch centrifugal style. That's good to around 14 to 15 gallons per minute. And we want to go beyond 15 gallons per minute. Again, we'll step over to our medium volume or our high volume Pro system. Like I mentioned, this one here starts at around 18 gallons per minute, 100 feet of pumping head, but it needs around 1,200 watts. And we'll step up from the 1/2 horse to a 1, a 1.5, a 2. And we get up to our 3 horsepower volume. That's going to be doing around 80 to 100 gallons per minute at probably around 200, 300 feet of pumping head. We do have one, we used to call it our XL Lake Maker. That one would do around, I think, 150 feet of pumping head, but it did 200 gallons per minute. Super popular when we're filling ponds or other high volume, high irrigation needs. Part of where the application they're going to talk to you about is, are you pumping muddy water? Are you pumping really dirty water? That might steer them towards a centrifugal. If you don't know, or if it's out of a well, majority of the time we're going to start with a helical, because we just don't have many issues when we're pumping out of a well with the helical style pump. Cool. Any other questions right now coming up?
Not at the moment.
Oh, I got a quiet group this time. Last group, a lot of questions coming in. But let's go over some real world examples of people installing this pump. These are customers who email in. We love to hear from our customers. You can check out our Instagram page. You can check out our website. We post almost every single photo that comes in from our customers. And now we get 10, 15, 20, 30 a day all over the United States, people sharing how they've installed these DIY systems to take control of their water supply with solar. So let's check this one out. This is for a Centrifugal 400V. I bought the pump to help keep a pond full and figured it wouldn't keep it full, but it would help maintain it till it rains. Super common application. Topping off a pond. These smaller ones can keep them topped off. If we really want to fill the pond in your dry location, some of these higher volume ones we'll use. As it turned out, I had to slow the pump down so the pond wouldn't fill as much and overflow. So Great example. The most common feedback we get on all of these pumps is, wow, I'm getting more volume than you guys told me than I was expecting. We size all these pumps for a 6-hour pumping day, but in actuality, and that's the solar day during winter when the sun rises later and sets earlier. We're doing around 6 hours of pumping per day, but in summer you're gonna get anywhere from 10 to 12 hours of pumping day. So you're gonna get a lot more volume, sometimes 30, 40, 50, 100% more volume than you're expecting. Like this guy who's using the 400V to keep a pond full. Super common application for these V series pumps. One of the things I love about that is because there is that upfront cost, right? We got to get the pump, we got to set the controller up, we got to install the panels. But once we do that, we never have to pay electricity bill again. So you can keep your pond full for years and decades without ever paying another bill to keep it full. I know others who use AC pumps to do that. They're always complaining in summer how much it's costing them to keep their pond full. They love their pond. They like being out their pond, but they don't like paying to keep it full every year. So, install it once, do the upfront installation and cost there. Never have to worry about keeping your pond full again. This one's for a Helical 400. Bought and installed the RPS 400 in May of 2021 at a depth of 146 feet in a well that had a static water level of 29 feet. Water storage tank was located 745 feet from the well and 42 feet above the well. The pump has worked flawlessly ever since and pumps 3.1 gallons per minute into the tank as long as there is enough sunlight. That is a super common installation. We have thousands of pumps in those types of wells doing that type of work day in and day out. 146 feet, great. That one, like I mentioned, is going to have 42 feet of additional pumping head. So we're going to add that on. I guess it's about 190 feet of pumping head. It's located quite a distance away, 749 feet away. Sometimes, depending on the volume of water and the diameter of that line, we might take into account frictional loss. Don't worry about that. We have sizing tools that our team uses and that are available on our website. If you want to calculate how much possible frictional loss you get at 3.1 gallons per minute and say a 1-inch line, we're not going to get very much. It's probably going to be 5 to 10 feet. So if we want to be careful, we add that on. And so we'd be looking in this case, probably about 200 feet of pumping head. And that's where this helical pump shines. The RPS 400, that's 4 smaller 100-watt solar panels. We're going to be able to pump that 200 feet of pumping head at 3.1 gallons a minute. And like I mentioned, 3.1 gallons a minute might not sound like a lot when you're looking at your garden hose shooting out 10 gallons a minute, 15 gallons a minute. But when we look over a 6 to 12-hour pumping day, that 3.1 gallons per minute turns into anywhere from 1,200 to 1,800 gallons per minute, which is quite a bit of water. That's enough for a household, and it's enough for quite a few livestock pairs if you're doing ranching. If you're doing a garden, that's going to be plenty of water for your garden. The only thing that's not going to work for is large irrigation, or say you're keeping a larger lake full. Then we'll switch over to the centrifugal style. Great. Let's talk a little bit more about efficiency of these pumps. And so these pumps that I'm showing you all here are going to be able to drive a direct drive. So that means when sunlight comes onto the panel, that sunlight's going to convert to energy, electricity. Electricity is going to flow through either the Pro controller or the universal standard controller for the 3-inch pumps. And that controller is going to take that power and it's going to drive the motor. So the thing about these motors is, depending on the speed they're spinning, that changes the amount of power that motor is consuming. So if we're spinning slow, they're not using much power. And we get up to full speed, which is around 3,600 RPM, 3,600 RPM, they're drawing maximum amount of power. And so we can vary the speed of that motor in order to match the exact solar condition. So with the helical style pump, when that sun kind of first cracks over the horizon, it's going to start pumping water at a very small trickle. It's going to spin very slowly. It's going to trickle up and out because of that efficiency I talked about with this pumping mechanism. Spinning real slow, and that water is being squeezed up and out. And we can squeeze it and push it out really slowly. So when the sun first rises, we're going to start to get a trickle of it. A couple hours later, 9 or 10 o'clock in the morning, we'll go up to full volume. We're going to run at that full volume throughout the whole day. We usually time it for 6 hours in winter. And so around 3, 4 o'clock, we're going to start to see that water volume taper off and down to sunset. And at sunset, it's going to go completely out. Unfortunately, even on a full moon, there's just not enough energy coming from that moon in order to pump at night, but a super common question. If we could pump at night when it's a full moon. Unfortunately, we can't. So that's how the helical style pump's going to pump. The centrifugal style, like I said, a little less efficient. So it's going to need a little bit more energy per gallon we're going to pump out. So in the morning, this one's going to start up a little bit later. Instead of like when the dawn, when the sun first starts to rise, probably an hour, 2 hours after sunrise. So we're looking more like 8, 9 o'clock in the morning where we start to see that ramp up, because this needs to run at least half speed before it's going to start producing any water. So unlike the helical, which can just kind of crawl here and pump a little bit of water, we got to get this one up to half speed. Don't worry, the controller takes care of all of that, so you don't have to think about that part of it. So it just takes a little bit more power to first get that trickle, and then same thing happens, but it happens a little bit quicker. The trickle starts, ramps up a little bit quicker to full speed because that sun's coming up quickly. We run at full speed throughout the day, and then we ramp down a little bit faster. Because this pump produces more volume, overall, you're going to get more water than a helical style pump, but it's just going to start a little bit later and end a little bit earlier. But both great options. Both get that common feedback of, hey, I'm pumping more water than I expected. I had to turn it down. These have speed controls. Most of the time you don't have to turn it down, but if you want less water, there are speed controls where we can turn down the maximum volume produced of the pumps. Cool. Any other questions?
None yet, but now it's a great time for you to throw in the questions. We got a little bit less than 15 minutes left.
Great. We got a couple minutes left. Great. Any questions showing up there?
None right here, but one I have heard recently from
Cool.
a couple of customers. Got a couple people reach out to me directly saying that they had solar panels on hand already.
Yep.
One of them said he had 6 solar panels on hand already. Now, assuming that those are the same type of solar panels that we use, which are for the most part 100 watt, 20 volts, 24 volts per panel.
Yep.
Which of these pumps would they be able to use with that sort of setup?
Yeah, for sure. Super common question is somehow the panel showed up. I pulled them off my roof after I upgraded it. Maybe I tore a shop down, pulled the panels out. Maybe my neighbor did that. I have extra panels laying in my barn somewhere else. Can I use it for these systems? So like Brendan mentioned, 2 most common sizes. When we're at the smaller system, we're using 100 watt panels, and they're a much smaller panel. We use those because they're super easy for one person to move around, to install. By yourself, you can lift them up. You can get them on a mount. You can mount them down. Just really easy when we're going less than 800 watts of power. When we step up to the Pro Series, we'll still use the 100 watts until we get about to the 1 horsepower level, maybe a little bit larger than that. And then we'll switch over to the 370 watt panels. And what a confusing thing is that's about 3.7 times larger than a 100 watt panel. So people think the panels are always the same, and we have these really giant 100 watt panels. No, that's not the case. The 100 watt panels are a lot smaller. When you get to 370 watt, they're about 5.5 feet tall and about 3.5 feet wide. So almost the size of a door. Really hard to install by yourself. You can't really get them up there, hold them in place while you tighten all the bolts like you can with the 100 watt panel. But we do that because when we get to these larger power systems, we don't want to do 20, 30, 40 of the 100 watt panels. We'd rather do anywhere from 4 up to 10 or even 20 of the larger panels. And so the question comes up is, I have these panels, can I use it with the system? And the answer is most of the time you can. We try to make these very modular. So we start with the base kit, which is always the pump, the controller, the solar panels. From there, you can add on either our mounting for the solar panels or your own mounting for it. And you can also add a turnkey kit. And the turnkey kit comes with everything you would need to install up to the outlet of the wellhead. So that includes the poly pipes, a lot of the stainless fittings, the well seal, and the fittings that go outside the well seal. So we try to make it super easy. But we also try to make it modular. So if you're already pulling a pump out and you have that other stuff, you don't have to get duplicates. You can reuse that to make it a more cost-effective solution. But the other thing we'll do is, if you have these panels, is we can remove the panels from the kit. So we can remove those so you can use your own. And we'll try our best to help you out. There's a sticker on the back of the panels usually. You can take a picture of that, and that's going to talk about the power of the panels, the voltage output, the current output. And our pump sizing team and our technical team can take that and tell you how many of those panels you'll need to either drive our 3-inch pump or our larger pumps. The considerations we take there is we don't want to over voltage the controller. The voltage input on the smaller controller is 100 volts. The voltage input on this controller, the Pro controller, is 450 volts. So we'll add up all those solar panels, make sure we get the right number in parallel and series to reach the power that these different pumps need. Brendan was kind of alluding to, can we mix and match panels? Can we take your panels along with some of ours and mix and match? The answer is we don't like to do that. We just find it causes more problems and is less cost effective for you in the long run because it causes more problems, more downtime of trying to figure out how to mix and match those panels. We really want the exact same panel specs when we mix and match panels. So we like to use all 100 watt panels with similar voltage output, all 370 watt panels with similar voltage output. We don't like to mix, say, a 370 with a 450. Those can cause weird voltage and current conditions where the smaller panel is actually current restricting the rest of the string and starts to drop voltage across it. You just get weird things happening there. So we like to stay with all one or the other. But if you have a whole pile of them, most likely we're going to take all those panels out and figure out how we can get all those to work for one of these kits.
We got one more from Todd. Does it matter where you set the pump speed depending on the sunlight or cloud cover?
Great question. So does it matter where we set the pump speed depending on the solar conditions, whether we have cloud or anything else? The answer is no. So majority of the time our customers just set that pump speed at 10, which is 100%, and they never touch it. What we have is our tank full sensor and our well low sensor for both of these systems. This one actually doesn't have a well low. It has that built in. Low well detection, we don't need a physical sensor. But when we're talking about these, we're going to have a low well and a tank full. That basically automates your whole system. So we put the well low system down maybe a foot or two above the pump. And if the water level in the well ever drops below that sensor, the controller is going to know that and it's going to shut the pump off so we don't run it dry. Helical pumps, because there is this physical motion and there's a lot of friction and heat that could potentially generate here, we really don't want to run the helical pump dry. That'll damage this rotor in about a minute or two if it's completely dry. Now, it comes with a little bit of food grade oil on there because we know people just love to really quickly fire that pump up on the surface, make sure it's spinning. So we put that on there. That quickly comes off. It's food grade, so it comes out as you first run your well. And so after that, no more running this thing dry. Don't even do it that first time. We like to run it always in a bucket of water. Centrifugal style pumps, a little more forgiving to running dry. A short check to see if they're running is going to be fine, but still we really like in the bucket. There's just not that friction going on with that heat generated really quickly. So I'm a little bit more tolerant to running dry. So like I said, we're going to have that sensor, that low well sensor above the pump. And if the water ever drops below it, we're going to shut the pump off and not run it dry. Same thing for our tank full behind us. From that controller, we're going to take our tank full sensor and drop it on the top of the tank there. And so as that water level rises up here and that sensor gets submerged, again, the controller is going to know it and it's going to shut everything off and stop running. And so that's why most people just run at full speed, because they'll pump as fast as they can out of the well. If the well can't keep up and it drops below, no big deal. The pump knows that, it shuts off, and it gives a time for that well to refresh. In the 3-inch controller, the universal controller, there's actually a timer in there from 0 to 30 minutes. And so if you have a low producing well, most people pump at full speed on 10, but then set that dial to 30 minutes. And so that means every 30 minutes, we're going to pump the well down until we hit the sensor. And then we're going to give it 30 minutes to rise back up. And then we're going to give it 30 minutes to pump back down. And so very automated system. So you don't have to mess with it. With those adverse solar conditions, like I mentioned, the controller knows exactly how much solar power is coming in. So it's going to vary the speed of the motor to match the exact solar conditions to use the most amount of power. So if you have a partially clouded morning, the controller is just not going to run as fast until those clouds pass. It's going to sense that there's more power available, and then it's going to ramp that motor up to full speed. So no, you don't have to adjust, say on a cloudy day, go out and try to turn it to half speed. The controller is going to do that automatically for you.
All right, we got time for one or two more questions.
Oh, cool.
We have one from David. This is a really good question. He's asking, how do I use solar with grid power on cloudy days, nighttime? So he's already got grid power at the place where he's running this pump. It sounds like that's back for less than great solar conditions or just pumping at night.
Great. AC backup and other options for pumping at night or other conditions. So our 3-inch line of pumps with the universal controller, 2 options there. We can add batteries that allows us to store pumping time for later. So those natively take batteries in. And like I said, I use that term very carefully, as it stores pumping time for later. So instead of storing our water in our tank, we store that electricity in the batteries to pump at nighttime or on cloudy days. But what it's not going to do is just adding batteries isn't going to magically generate more power for the system. We're still going to be limited to around the 6 hours of pumping per day, but we can shift that time. So if we're not pumping during the day, or say we're only pumping 2 or 3 hours during the day, we can shift some of that pumping by storing that power in our batteries for nighttime. So you maybe pump 3 hours during the day, 3 hours at night, using this automated system, turning it on and off. Your second option is the controller doesn't natively take in AC power, but we do have a power converter that takes the AC power and converts it to DC for the pump to run. So a lot of guys will keep that in their truck or with a generator if they really need to. Say you don't have enough water storage. We like to always encourage 3 to 5 days of water storage. But let's say something happens and maybe you lost all your water in your tank and it's cloudy, and you really need to pump some, then you can use a generator or utility power if you have it there and hook up the converter. There's even an auto switcher that's more popular these days for off-grid, or not for off-grid, but for household systems where they're doing pressure with one of these 3-inch pumps. That'll auto switch back and forth. So we add that on. It has the power converter in there. Then it has a little circuit in there that switches back and forth. Always they prioritize solar. So if there's enough solar available, we'll run off solar. And then if there's not enough solar available, we either run batteries, or if you don't have batteries, we'll run off of AC and make that auto switch. The Pro system, very nice. It doesn't have battery input, so we can't hook up batteries to this because it's just too high a power, too high a voltage. But this controller can take 220/240 volt single phase AC and natively, and then it'll do that same thing. If there's enough solar available, it'll run off of solar, or it can auto switch into the AC power. But that's just all built in. When we have the 3-inch smaller pumps, we have to add an outside converter, outside circuit to do all that work. So great question. A lot of options. Very versatile. We've designed and added on whatever we can because we've gotten that question 1,000 times. And it's like, yeah, we'll add on this auto converter and auto switcher to help that person out. Great. We have one more question.
Got time for one more question if somebody gets it in right now.
Cool. Well, while we're seeing if there's other questions, really appreciate everybody joining us today. Like I mentioned, this is the third part of our 4-part September virtual field days. We're trying to come to you guys live, answer these questions real time about these systems, and help make your selection process easier. Covered a lot of information today. We do have a full pump sizing team. We have a lot of people who are super knowledgeable in all of the things I talked about today, the pros and cons, the different applications. So like I said, if some of this sounds a little confusing or just not quite sure, give us a call. The number is 888-4... Oh, what's the number again? 888-637-4493. Give us a call. We'll walk you through your application, how much water you need, and what's going to be the right kit for you. Great. Did we get that last question in? All right. If you know what happens to me is right after we shut this off, the question's going to jump into my head. And so shoot us an email if that question jumps in, or give us a call. We're happy to answer. There are no dumb questions here. Everybody here started, all the pump sizers started as beginners. They've learned all of this over their whole training, and they love sharing it, talking to customers, talking about solar water pumps, especially the DIY aspect, how you can save thousands of dollars installing one of these systems yourself. You can also text us at that number. If that question comes up, shoot us a text at that 88 number. You can also send us an email, service@ruralpowersystems.com. We'll put all that in the description of the YouTube video if you need to go to it. You can also jump on our website. There's live chat on the website. We'll answer all those questions real time if it jumps into your head right after here. So really appreciate everybody joining us. I'm super excited about next week's virtual field day. Went in a little more depth than I was thinking we would today on the Pro system, but that's why I brought the controller out, because I thought it'd be a good intro to next week. We're going to take a deep dive next week. We're going to talk about deep well submersible pumps, but we're also going to talk about the less common irrigation pumps, dewatering/grinder pumps. We have this pump called the GB Booster. It's a pretty crazy looking pump that produces high pressure with a surface pump. I'm going to talk about that one. And then some of our high volume, high pumping head. This controller here tops out around 5 horsepower. Then we switch over to our Big Ag controller. That goes from anywhere from 7.5 up to 100 horsepower system. So when we're talking about those big industrial farmers, industrial scale irrigation, we'll swap over that Big Ag. I'm hoping we'll have a couple of those pumps here to show you. So join us same time next week. You'll be grabbing an email about it if you want to pre-register, but can't wait to see everybody. Thanks for joining us today. Again, Mike with RPS Solar Pumps, and just really appreciate sharing my love of solar pumping with you all.